Welcome to CSE Guru. In this session, we will discuss about the basic concepts of process and process states. A process is nothing but program and execution. The program is nothing but a stable program code or simply an executable file. So, when this program is loaded into the memory for execution, that time we will call that program as a process. This process will consist of program, that is nothing but program code, input, output, and process states. The main difference between program and process is program is a passive entity and process is an active entity, because program will consist of list of instructions stored on a disk. So it is a passive entity. When this program code is loaded into the memory for execution, or this program is assigned to the CPU for execution, that time we will call it as a process. So process is an active entity. During process execution, the address of the next instruction will be stored with the program counter, and this program counter also stores the associated resources for process execution. Example for the process includes the web browser program tabs. That is, if you are opening more than one tab, each tab represents a single process. This is the structure of the process in memory. The process may include these process stack, heap, data section and text section. That is, each process will have all these sections in memory. The stack section is used to store the temporary data during process execution. That is, the local variables, return address, or the function parameters. So these informations will be stored with the stack data structure temporarily. And during execution, process may require to allocate a memory dynamically. The dynamic memory allocation is provided by this heap data structure. And the data section includes the global variables, the variables used throughout the program as well as the functions. And the text section is nothing but the actual program code, that is a compiled program code, nothing but the executable files. Next, process states. Each process may be in one of the following states. That is, each process, once it is assigned to the CPU for execution and till it completes its execution, it may switch in between these 5 states. So these 5 states are new state, running, waiting, ready and terminated. When a process is newly created, that time the process will be in new state. When the process is assigned to the CPU for execution, that time the process will be in running state. When the process needs to be serviced by any other IO devices, that time the process will switch to waiting state. Once the IO request is serviced, the process will switch from waiting state to ready state. When the process completes its execution, the process will be in terminated state. And this is the process state diagram with the 5 states: new, ready, running, waiting and terminated. So new state is nothing but when the process is newly created and the process needs to execute with the CPU, that time the process will be in new state. And when this process, that is the program code, is loaded into the memory for execution, it will be admitted to the ready state. So once the program code or the executable file is loaded into the memory, the process will switch from the new state to the ready state. That is, the process is ready to be assigned to the CPU. Processes in ready state will wait for the CPU. When it gets free, automatically it will be assigned to the CPU for execution. So from the ready state, the scheduler, the process scheduler will dispatch one of the job from the ready state and that will be assigned to the CPU. So once the process is assigned to the CPU for execution, the process will switch from the ready state to the running state. So this running state is nothing but currently the process is executing with the CPU. When the interrupt or any event occurs in the sense, automatically the process will switch from running state to ready state. During process execution, if the process needs to be serviced by any other IO devices, so the process will switch from running state to the waiting state. So in waiting state, the process will wait for the IO devices to be serviced. When the IO event is completed, the process will switch from the waiting state to the ready state. And from the ready state, when the CPU is free, the dispatcher will assign one of the process to the running state. Once the process completes the total execution, the process will switch from the running state to the terminated state. So here the process will exit with the CPU. So this represents the process state diagram. So in the process life cycle, if you are considering, the process will switch from one state to the other state according to the requirement of the process to complete its execution. Thank you for watching this video.